Today's lesson is about practice for logarithm rules. Part 1, expanding the logs. Let's go over the rule for logarithm. Multiplication of an argument, we add log. Division of an argument, we subtract the log. Power of an argument, we multiply that log. Therefore, for A, first of all, we working on power of a power. We got the log base 2 of power of power. We multiply the exponents. Here's the rule. Therefore, we got the x to the 10th power, y to the 5th power, z we do the 5th power. We all have a multiplication of an argument. Therefore, we add the log. So we got the x to the 10th power plus log base 2 y to the 5th power plus log base 2 z to the 5th power. Then you're using this rule, drop down the exponents, do the multiplication. So we got 10 multiply log base 2 of x, which means whenever you have exponents, drop down. So we got plus 5 log base 2 of y, then plus 5 log base 2 of z. Now let's go to number B. First of all, you have to change the argument into exponential form. Therefore, you got x squared, y to the 1/2 power, z you do 1/3 power. When you have a division, that means you do subtraction. Therefore, you got log base 2 of x squared plus log base 2 of y to the 1/2 power. Then subtract log base 2 of z to the 1/3 power. Last step, drop down the exponents. So we got 2 log base 2 of x plus 1/2 log base 2 of y plus 1/3 log base 2 of z. Now let's go to C. Log base 2 of x to the 6th power. Denominator, you got to use a subtraction. Log base 2 of z minus log base 2 of y to the 5th power. Then drop down the exponent. So we got 6 log base 2 of x minus log base 2 of z minus 5 log base 2 of y. Now let's go to D. You will get the log base 2. You change argument into exponential form. So we got the x, y, z squared. You do 1/3 power. Then power of a power, you will multiply by exponents. Therefore, we got x to the 1/3 power, y to the 1/3 power, z you got to do 2/3 power. Now, since it's all multiplication, we add the log. So we got log base 2 x 1 over third power plus log base 2 y to the 1 over third power plus log base 2 z to the 2 over third power. Then last step, drop down the exponent. So we get 1 over 3 log base 2 of x plus 1 over 3 log base 2 of y plus 2 over 3 log base 2 of z. Now let's go to E. You will get the log base 7 of y third power x to the 1 over fourth power. Division of argument, you got to subtract the log. Therefore, we got log base 7 of y to the third power minus log base 7 of x to the 1 over fourth power. Last step, drop down the exponent. So we got 3 log base 7 of y minus 1 over 4 log base 7 of x. Let's go to H. Still, first of all, we need to change the argument into exponential form. So we got log base 3 of x to the 1/2 power, b and c squared. Then we got any factor below division line, you got to do subtraction. So we got log base 3x to the 1 over half power minus log base 3 of b minus log base 3 of c to the square. Then you need to drop down the exponent. So we get 1/2 log base 3 of x minus log base 3 of b minus 2 times log base 3 of c. Part 2, condense the logs. For condensing the log, here's the formula. Addition of a log, we multiply the argument. Subtraction of log, we do the quotient of argument. Number you multiply by log, we jump at the exponent, m to the kth power. For number 1, first of all, you have to clear the number before the log. You make that jump at the exponent. Therefore, we got log base 3 of k to the 1/2 power minus log base 3 of p squared plus log base 3 of 2 to the third power. Then now we're condensing the log. We got the log base 3. You have one single log. Subtraction means division. So p to square go to denominator. K to the 1/2 power, you have to turn into square root of k times 2 to the third power, that's 8. This will be the answer. If you want to, you can organize as a log base 3 of 8 square root of k over p squared. Now let's go to number 2. Still, clear the number before the log. So we got log base 3 of 25 to the 1/2 power. So we got the minus log base 3 of 6 square plus log base 3 of 12. For 25, do the 1/2 power, that means square root of 25 equals 5. Therefore, we got log base 3, division line. 6 squared, that 36, go to denominator. Then 5 times 12. Then you go to reduce. So you get log base 3 of 5 over 3. Now let's go to number 3. Jump as exponent. So we got log base 3 of square root of x minus log base 3 of y to the 3rd power minus log base 3 of z squared. Now we're condensing the log. Subtraction means division of argument. Therefore, y to the 3rd power times z squared go to denominator. Square root of x go to numerator. That's all. Now go to number 4. Still, we need to clear the number before log. So jump as exponent. You will get the log. This is a common log of x to the 3rd power plus common log of y squared minus common log square root of z. Remember, z to the 1/2 power equals square root of z minus log cubic root of w. Because w to the 1 over 3rd power means cubic root of w. Therefore, we're condensing the log now. Whenever you see the subtraction means you have division line. So we got x 3rd power times y squared, square root of z times cubic root of w. That's all. Now let's go to number 5. We got common log of square root of 9 plus 2 minus common log of 24. For 2, we know any number n I can write down log base a of a to the nth power. Therefore, for this 2, I can write down common log of 10 squared. So we got the common log of 3, square root of 9 is 3 plus common log of 10 squared minus common log of 24. Now we're condensing the log. Common log of, we have division line. 24 go to denominator. Subtraction means division of argument. So we got 3 times 10 squared. That means 100. Then we reduce now. This is 1. Here's 8. Then 2, 25. Therefore, we got common log of 25 over 2. For number 6, this is a natural log. Still, clear the number before the log. So we got the natural log of x to the 3rd power plus 3. I got to use this formula. I got natural log of e to the 3rd power minus natural log of z to the 1/2 power means square root of z. Now we're condensing. This is a natural log. We have division line because we have this subtraction. We got square root of z as denominator. X third power times e to the third power. That will be the answer. Part 3, evaluate the log. We got to use the following logarithm formulas to evaluate the log. First of all, log base a of a to the r's power equals r. Because we know a to the r squared equals to a to the r squared. Therefore, common log of 10 to the x power equals x. Natural log of e to the x power equals x. This is a very useful formula. Log base a to the nth power of a to the mth power equals m over n, because a to the nth power of m over n equals a to the mth power. Sometimes we got to use inverse rule to evaluate the log. For number 1, this is a common log. First of all, you have to change the argument into exponential form. 10,000 I can change into 10 to the third power. Therefore, fourth root of 10 to the third power equals 10 to the 3 over fourth power. Because nth root of a to the mth power equals a to the m over nth power. Therefore, I can write down 10 to the 3 over fourth power. Then you use this rule. You will get 3 over 4. For number 2, natural log. We know the natural log, the base is e. So you got to change 1 over square root of e into e to the negative 1/2 power. Therefore, you will get the negative 1 over 2. For number 3, base is 25. Argument is 1 over 125. You can make a common base as a log base of 5 squared for 25. 1 over 125, I can write down 5 to the negative third power. Therefore, we got negative 3 over 2 because of this formula. For number 4, still you need to change into base 3 to the power for base and also the argument. Therefore, we got log base 3 to the 1/2 power. Then 1 over 9 I can change into 3 to the negative second power. Therefore, we got negative 2 over 1 over 2. This is a complex fraction. Therefore, you got negative 4. Now go to number 5. For 1 over 16 and 32, we know we can make a exponential form. The common base is 2. So we got the log 2 to the negative 4th power. 32, that means 2 to the 5th power. Therefore, get the 5 over negative 4 equals negative 5 over 4. For number 6, I will get the log base 6 to the negative second power. 1 over 6, that's 6 to the negative first power. Therefore, we got negative 1 over negative 2 equals 1 over 2. For number 7, you have to use this inverse rule. Try to make the same base like 125. We know 5 to the third power equals 125, which means from 125, we do 1 over third power, we get 5. Therefore, we got 125 to the 1 over third power. Then you do the log base of 125 of 10. Then make 1 over 3 jump as the exponent. You will get 125 log 125 of 10 to the 1 over third power. Therefore, this is gone. You will get the cubic root of 10. Now let's go to number 8. We will make a base into 2. Therefore, 4 I can write down 2 squared. Then multiply by log base 2 of 7. Then this 2 we jump as exponent. You will get the 2 log base 2 of 7 squared. This is gone. 7 squared equals 49. For number 9, you got to change 3 into 81. 3 to the fourth power equals 81, which means 81 to the 1 over fourth power equals 3. Therefore, 3 I will turn into 81 to the 1 over fourth power. Then I do log base 81 of 10. 1 over 4 jump as exponent. You will get the 81 log base 81 of 10 to the 1 over fourth power. This is gone, so we got fourth root of 10. For number 10, I will change 25 into base of 5. So we got the 5 squared log base 5 of 12. Then for this 2 jump as exponent, you will get the 5 log base 5 of 12 squared. This is gone. You will get the 144.